The current model of atomic structure was not understood until the 20th century. Initially, atoms were thought to resemble plum pudding, but in 1907, Ernest Rutherford conducted an experiment that debunked the accepted plum pudding model and led to the discovery of the atomic nucleus. According to the plum pudding model, atoms consisted of diffuse, positively charged matter spread in a spherical shape. Embedded in this positively charged sphere were the negatively charged electrons, such that the electrons resembled plums in a plum pudding, and the overall charge of the atom remained neutral. Rutherford's experiment, which we will perform in a minute, involved shooting a beam of tiny, dense, positively charged alpha particles at thin metal foils. The hypothesis, consistent with the plum pudding model, was that the beam of alpha particles would pass straight through the atoms in the foil with very little deflection of the particle beam. The basic experimental setup for Rutherford's experiment involves a block of radium, which is a source of alpha particles, inside a lead block with a hole to produce the beam of alpha particles. A thin metal foil, such as gold foil, placed such that it would interrupt the beam of alpha particles. A circular fluorescent screen to detect the beam of alpha particles. To begin the experiment, click on the lead block to open the hole and allow the particle beam to be emitted. Did the experimental results match our hypothesis based on the plum pudding model? Why or why not? Did you notice the major deflection of the particle beam? Rutherford himself stated, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you." These rare major deflections are not consistent with our hypothetical plum pudding model of the atom. In order for Rutherford to explain the results of his experiments, he proposed that the major deflections were caused by the alpha particles being repelled by something small, dense, and positive within the atoms of the foil. What could this be? Rutherford called the small, dense, positive mass the nucleus. How would this model of the atom affect the results of Rutherford's experiment? Rutherford's experiment illustrates how unexpected experimental results can lead to important scientific discoveries like the atomic nucleus.